In the past, we had data warehouse. They were rigid, expensive, and only liked structured data. But today, we live in a world of logs, images, and streaming clicks. To handle this, we need a data lake. A centralized repository that allows you to store all your structured and unstructured data at any scale. And at the heart of almost every modern data lake is AWS S3. Why S3? Because it solves the three biggest problems of big data: scaling, durability, and cost. S3 provides 11 nines of durability and can scale to exabytes without you managing a single server. Crucially, it decouples storage from compute. This means you can store your data cheaply in S3 and only spin up expensive CPU power when you actually need to query it. A robust S3 data lake is built in layers. We start with ingestion, then move to tiered storage, followed by processing and cataloging, and finally, consumption. Think of it as a factory. Raw materials come in at the back, get refined on the line, and finished products come out the front. Let us walk through each stage of this architectural blueprint. Data comes from everywhere. For real-time streams like website clicks or IoT sensors, we use Amazon Kinesis. For database migrations from your on-premise servers, we use AWS Data Migration Service or DMS. And for SaaS apps like Salesforce or Zendesk, we use Amazon AppFlow. All these tools have one thing in common: they are designed to dump data directly into S3 at high velocity. When data first arrives, it hits the landing zone. This is a private S3 bucket where data is stored in its original, raw format. We don't change anything here. This is our source of truth. If a processing job fails or requirements change next year, we can always come back to the landing zone and reprocess the raw data from scratch. You don't just dump files into a bucket. You must partition them. Partitioning means organizing your data into a folder structure, usually by date or region. For example, year equals 2026, /month equals 01, /day equals 26. This allows tools like Athena to skip 99% of your data and only read the specific folder it needs. Good partitioning is the difference between a query taking 5 seconds or 5 minutes. Most raw data arrives as CSV or JSON. These are great for humans, but terrible for big data. In the processing layer, we convert this data into columnar formats like Apache Parquet or Avro. Parquet compresses data significantly, saving you storage costs. More importantly, it allows query engines to read only the columns needed, which slashes your query costs and increases speed by 10 times. After partitioning and format conversion, the data moves to the trusted zone. Here, it is cleaned, missing values are handled, and schemas are enforced. Finally, it reaches the refined zone. This is where data is joined and aggregated into business-ready datasets. This tiered approach ensures that users only access high-quality, reliable data. How do we know what is actually inside those millions of files? We use AWS Glue. Specifically, the Glue crawler and the Glue data catalog. The crawler scans your S3 buckets, identifies the schema, and creates a virtual table definition in the catalog. This catalog acts as a central library, telling every other AWS service exactly how to read your S3 data. A data lake is useless if it is not secure. Managing S3 bucket policies for thousands of users is a nightmare. Instead, we use AWS Lake Formation. It provides a single place to define fine-grained access control. You can grant permissions down to the specific row or column level, ensuring that your HR data stays private while your sales data remains accessible. Now that our data is stored, cataloged, and secured, how do we use it? The most common way is Amazon Athena. It is a serverless, interactive query service that lets you analyze data in S3 using standard SQL. There is no infrastructure to manage. You only pay for the amount of data scanned by your query. This is the fastest path from raw S3 data to business insights. For massive scale transformations or machine learning, we use Amazon EMR. EMR allows you to run Spark, Hive, or Presto clusters that scale out to hundreds of nodes. These nodes read directly from your S3 data lake, process the information, and write the refined results back to S3. It is the heavy-duty engine of the data factory. If you already use a Redshift data warehouse, you don't have to choose between a warehouse or a lake. Redshift Spectrum allows you to run SQL queries against exabytes of data in S3 without loading it into Redshift first. This hybrid approach gives you the performance of a warehouse for your hot data and the scale of a lake for your cold historical data. Because your entire business now depends on the data lake, you must protect it. Enable S3 versioning to protect against accidental deletes. Use cross-region replication to mirror your refined data to a different AWS region. This ensures that even in a complete regional failure, your data assets remain safe and available. Building a data lake on S3 is about more than just storage. It is about building a scalable ecosystem for ingestion, tiering, cataloging, and analysis. Start with S3, automate with Glue, and query with Athena. You now have the blueprint to turn your raw data into a competitive advantage. Follow @Cloud Decoded for more cloud architecture deep dives. Thanks for watching.